Using 10-gauge copper wire with a 40-amp breaker is an electrical safety hazard. The fundamental principle at play here is that the ampacity, or current carrying capacity, of a wire must be equal to or greater than the rating of the circuit breaker protecting it. This is to prevent the wire from overheating and potentially causing a fire. 10-gauge copper wire, according to the National Electrical Code, or NEC, has a maximum ampacity of 30 amps under typical installation conditions. This means it's designed to safely handle up to 30 amps of continuous current. A 40-amp breaker, on the other hand, is designed to trip or interrupt the circuit when the current exceeds 40 amps. If you connect 10-gauge wire to a 40-amp breaker, the breaker will not trip until the current exceeds 40 amps. However, the 10-gauge wire may overheat at a current level well below 40 amps, potentially leading to insulation damage, melting, or even a fire. The relatively short length of the wire, in this case 8 feet, does not negate the risk. While a shorter wire length might slightly reduce voltage drop, it does not significantly increase the wire's ampacity or its ability to safely handle higher currents. The NEC specifies ampacities for different wire gauges based on standard conditions, and these values are independent of the wire length for typical residential and commercial wiring applications. To ensure safety and code compliance, you must choose a wire gauge that is appropriate for the breaker size. For a 40-amp breaker, you should use at least 8-gauge copper wire. 8-gauge copper wire has an ampacity of 40 amps under typical installation conditions, making it suitable for use with a 40-amp breaker. However, it's always a good practice to consult the NEC or a qualified electrician to determine the correct wire gauge for your specific application, as various factors can affect the required ampacity, including ambient temperature, the number of current carrying conductors in a raceway or cable, and the type of insulation. The NEC provides tables that adjust ampacity based on these factors. The principle of overcurrent protection is a cornerstone of electrical safety. Circuit breakers are designed to protect wiring from overloads and short circuits. An overload occurs when the current in a circuit exceeds the wire's ampacity, but the circuit is still functioning normally. A short circuit occurs when there is a low resistance path between two conductors, resulting in a very high current flow. In either case, the circuit breaker is intended to trip and interrupt the circuit, preventing damage to the wiring and reducing the risk of fire. To properly size a circuit breaker and wire, you need to consider the load that the circuit will be supplying. The load is the electrical device or equipment that is connected to the circuit. Each load has a specific current draw, which is the amount of current that it requires to operate. The total current draw of all the loads on a circuit must not exceed the ampacity of the wire or the rating of the circuit breaker. It's also important to consider the starting current of certain loads, such as motors. Motors often draw significantly higher current when they start than they do during normal operation. The circuit breaker must be sized to handle this starting current without tripping. The NEC provides guidance on how to size circuit breakers for motor circuits. In addition to wire gauge and breaker size, there are other factors to consider when wiring a circuit. Firstly, you must use the correct type of wire for the application. Different types of wire are designed for different environments and uses. For example, THHN wire is commonly used for general-purpose wiring in dry locations, while THWN wire is suitable for wet locations. Secondly, you must properly install the wiring. This includes using the correct connectors, making sure that all connections are tight, and protecting the wiring from physical damage. Improperly installed wiring can create hazards such as loose connections, which can cause overheating and arcing. Thirdly, you must follow all applicable electrical codes. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years and is adopted by most jurisdictions in the United States. Following the NEC helps to ensure that electrical installations are safe and compliant with regulations. When working with electricity, it is always important to exercise caution. Electricity can be dangerous, and even a small shock can be harmful. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. It is also very important to turn off the power at the circuit breaker before working on any electrical circuit. This will help to prevent electric shock. Always use insulated tools when working with electricity. Insulated tools are designed to protect you from electric shock. Never work on electrical circuits in wet conditions. Water is a good conductor of electricity, and working in wet conditions can increase the risk of electric shock. Be aware of your surroundings. Make sure that there are no exposed wires or other electrical hazards in the area where you are working. If you see any hazards, take steps to correct them before starting work. If you are unsure about anything, ask for help. There are many resources available to help you learn about electrical safety. You can consult the NEC, take an electrical safety course, or talk to a qualified electrician. By following these safety tips, you can help to prevent electrical accidents. In summary, using 10-gauge copper wire on a 40-amp breaker is a safety hazard because the wire's ampacity is lower than the breaker's rating. For a 40-amp breaker, use at least 8-gauge copper wire. Remember to consult the NEC and follow all applicable electrical codes to ensure a safe and compliant installation. Always prioritize safety when working with electricity, and if you're not comfortable, hire a qualified electrician. Also, be sure to inspect the condition of all wiring to ensure that it has not become damaged, cut, or frayed over time. Damaged wires can also become a fire hazard if left unchecked. The general formula that relates power, voltage, and current is P equals volts times amps, where P is power in watts, volts is voltage in volts, and amps is current in amps. This is important to note as it provides guidance on the ratings of the wires and breakers. Knowing the voltage and amperage that a circuit supplies allows you to calculate the power in watts that the circuit can provide. This calculation is crucial for determining whether the circuit can handle the load of the equipment or appliances connected to it. The standard voltage in most residential electrical systems in North America is 120 volts for smaller circuits and 240 volts for larger appliances like stoves and dryers. In commercial settings, it's common to find 208 volts, 277 volts, and 480 volt systems. Understanding these voltage levels is critical for selecting the right electrical components and ensuring safety. Different types of circuit breakers are designed for specific applications. Firstly, standard circuit breakers are the most common type used in residential and commercial settings. Secondly, ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which occur when current leaks to ground. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Thirdly, arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which are dangerous electrical arcs that can cause fires. SIs are required in many areas of the home, particularly in bedrooms. The NEC provides guidelines on the types of circuit breakers required for different applications. The NEC is not just a set of rules, but a comprehensive guide to electrical safety. It covers everything from wiring methods to grounding and bonding requirements. Electrical inspectors use the NEC to ensure that electrical installations are safe and compliant. Understanding and following the NEC is essential for anyone working with electricity. Wire insulation plays a critical role in electrical safety. It prevents current from leaking out of the wire and causing shocks or fires. Different types of insulation are designed for different environments and applications. For example, THHN insulation is heat resistant and suitable for dry locations, while THWN insulation is water resistant and suitable for wet locations. Selecting the right type of insulation is important for ensuring the safety and reliability of an electrical installation. When working with aluminum wiring, it is crucial to use connectors and devices that are specifically rated for aluminum. Aluminum wiring expands and contracts more than copper wiring, and using incompatible connectors can lead to loose connections and overheating. The NEC provides guidance on the proper use of aluminum wiring. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and clear the fault. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Proper grounding and bonding help to prevent electric shock and reduce the risk of fire. Electrical boxes are used to protect electrical connections and devices. They come in different sizes and shapes and are made from metal or plastic. The electrical boxes must be properly sized to accommodate the wiring and devices that they contain. They must also be securely mounted to prevent them from coming loose. Conduit is used to protect wiring from physical damage. It is typically made from metal or plastic and comes in different sizes and types. Conduit must be properly installed and supported to prevent it from sagging or becoming damaged. Voltage drop is the decrease in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or overheat. To minimize voltage drop, it is important to use the correct wire gauge and to keep wire runs as short as possible. The NEC provides guidelines on acceptable voltage drop limits. Electrical panels are the central distribution point for electricity in a building. They contain circuit breakers that protect the circuits from overloads and short circuits. Electrical panels must be properly sized to accommodate the load of the building. They must also be kept clean and dry to prevent corrosion and electrical hazards. Surge protection is used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other electrical disturbances. Surge protectors divert excess voltage away from the equipment, preventing damage. The NEC provides guidance on the use of surge protection. When installing electrical wiring, it is important to follow the correct wiring methods. This includes using the correct type of wire, making sure that all connections are tight, and protecting the wiring from physical damage. The NEC provides detailed instructions on wiring methods. Electrical safety is everyone's responsibility. By following safe practices and adhering to the NEC, you can help to prevent electrical accidents and ensure the safety of yourself and others. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. They have the knowledge and experience to safely and effectively install and repair electrical systems. In addition to these specific points, it's important to remember that electrical codes and best practices can change over time. Staying updated on the latest revisions to the NEC and other relevant standards is crucial for ensuring that your electrical work is safe and compliant. Continuing education and professional development are valuable investments for anyone working in the electrical field. Also, remember to consider energy efficiency when designing and installing electrical systems. Using energy-efficient lighting, appliances, and wiring can help to reduce energy consumption and lower utility bills. The NEC and other standards provide guidance on energy-efficient electrical practices. When dealing with older electrical systems, it's important to be aware of potential hazards such as deteriorated wiring, outdated components, and non-compliant installations. Older systems may require upgrades or replacements to meet current safety standards. A qualified electrician can assess the condition of an older electrical system and recommend appropriate solutions. Furthermore, it is good practice to consider future electrical needs when planning an electrical installation. Adding extra circuits or increasing the capacity of the electrical panel can provide flexibility and accommodate future expansion. This can save time and money in the long run.